Okay, so for this first one, he made the mistake of, well, one person might say, well, he added the numerators and added the denominators. That's the mistake. Well, why is that a mistake? And that's kind of the meat of this problem. And like we talked about in class on Monday, when you get tenths, whoops, that's wiggling on me. When you get tenths, that means your whole has been divided into 10 parts, where the original problem is saying your whole is divided into 5 parts. So Cade's mistake is that he's changed the whole. And he's changed the whole from this to 2 of those. You know, they're just below each other. But that's still 2 of those bars is what he's thinking of as the whole. So I'm looking for something about that whole being changed. Alright, so for this one there's a couple ways you can do it. Probably the easiest way is to look at these as, you know, comparing the numerators might be the easiest way. So if you look at 4/5 as 8/10, then we can compare 8/10 and 8/9. And we can say, well, we know that if we take a whole and divide it into 10 parts, those little parts are smaller than if we took a whole and divided it into 9 parts. So 8 of these smaller pieces would be smaller than 8 of these larger pieces. So 8/9 is larger than 4/5. So this is the common numerator way. Okay, and then another way is to compare it to a whole. And you could say, well, 4/5 is 1/5 from a whole, and 8/9 is 1/9 from 1. So using that same reasoning as we did over here, we can say that a whole divided into 5 parts would result in bigger pieces. So we know that 1/5 is larger than 1/9. So if we think about a whole, and the 1/5 is larger, so we're further away from the whole when we're at 4/5 than when we're at 8/9, because a little tiny 9th is smaller than a 5th. So that's one way, or another way, I guess you could say it. And then I just wanted to make a comment for those of you that used a picture. I mean, this one, when you have fractions that are so close to 1 or so close to the same fraction, I guess, the pictures don't work very well. So let me give you an example. Let's say you try to use a rectangle to show me your, what do we have here, 4/5. And if we were really precise, which I'm not, but I'm going to try to be better than usual. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 4/5 and 8/9. 1, 2, 3, 4, 5, 8. I mean, look at how close those are. And so in some of your pictures, you're making it very obvious, but you're not really drawn to scale. So that's why for this problem, a picture is not a good idea to use. I want you to be using common numerator or this comparing to 1.